Hi and welcome. In this video I want to show how you can use symbols as declared in declarations in your programming. So first let me declare some symbols. I could have a symbol called my age, you've seen that before, and I say that it equals 28. Enter. So with this command the symbol my age has been inserted into the symbol table with the corresponding value 28. Good. So now I can start using this in my further programming. I can have, well, my age next year, and I can say that this one is equal to my age plus 1. So in this expression I have referred to stuff that was in my simple table. My age is looked up in the simple table and will return, that is, evaluate to the corresponding value, that is 28. The number 1 is looked up in SML's internal simple table. It knows what a number evaluates to and it just returns that value. The whole thing is then evaluated, that is, this plus operation is performed in the moment that I declare this symbol and is assigned to the symbol my age next year in the simple table. So now I have two things in my simple table and I can start programming using these two. You may have noticed this colon int that is concatenated to the value here, and the same here, colon int. This means that the type of this value is an integer, which in Danish would be heltal. And actually, I haven't told you, but this type thing is also something that you can see in the simple table. The simple table has a third column in which the type is declared or stated. And this means that you cannot, it knows whether two things can work together. For example, in this expression, these two things would have to be of the same type before the expression can be evaluated, and that is because this plus symbol demands that the two arguments or addenda is of the same type. Okay. You can declare other types of values than just such numbers. For example, you can declare values of type functions. They look like this. So this is a symbol that has the value of a function. A function is written as fn and then a parenthesis, and in this parenthesis I have to write which arguments or parameters, as it is more precisely, my function takes. So I want my function to take 2 arguments and current age and years in future. So it takes 2 arguments, and what does it do? Well, it adds them up. Oh, I see I made a little. Can I go back? I can go back. Years in future. So current age plus years in future. Good. So this should be my new fancy function value. Oops. So it's not completely satisfied. Oh, there has to be, can I copy this? Nope. Okay. Well, my first function equals a function declaration. So this whole expression is a function expression, and when it is evaluated, it returns a thing called a closure, and then this closure is put into the symbol table and referred to under the simple name my first function. So what's special about these function values or closures is that they do not just have kind of one value, or yes they do, but their property is that they can take these arguments and thereby evaluate to something else. Whatever they evaluate to depends on what you give as arguments. You know it from primary school, the concept of functions. So you can say in a sense that a closure is a value, and it is a value because it sits in the symbol table and it has a name just like all the other values, but it's not an atomic value, and it's not atomic because it can be evaluated further. If you do something to it, it can evaluate to something else. So it kind of corresponds to, say I have this value declaration, instead of SML just hurrying up, evaluating the expression and then just putting the result of the evaluation into the symbol table under the name myH, it kind of stores the whole expression for later computation. Well, this is a bad example because there's no arguments, but you get the point. There was an argument in the function value. Okay, so let's try it out. My first function, and I give it some arguments. Oh, wait a bit. I first have to make it a declaration. So now I want to make a symbol that has the value that is returned when I call my function with some arguments. Let's have a look. Well, my future age in 5 years. So that will be my first function with the arguments current age, that's 28, and years into the future, that was 5 years. So let's have a look. Ta-da! So what you see now is the symbol my first function has been made to return a value, in this case 33, when I gave it some specific arguments. And the symbol my first function, as you know, refers to the closure or function body I defined up here, my first function. So when I give some values to this value that is referred to by the simple name my first function, it returns another value. It's amazing. In this way, by building up a set of symbol names that refer to relevant values, I can construct a program that kind of builds up like a pyramid, defining some simple values to start with, and then creating functions and calling these functions to create more and more complex values, or at least values that get closer and closer to the end result that I'm trying to reach. And that's basically what programming in SML is all about. Building values, building upon existingly declared values, and then getting to where you want. And one last thing is, I just want to show you, there's a shorthand notation for declaring functions, so we don't have to write such long things as this one. It goes like this. but my very short function takes an argument, my age, a bit boring, I admit, equals my age plus 2. Yes. So here what happens is exactly the same almost as up here. You have a name that is a symbol, and what goes into the symbol table is a function that takes an argument. Now just the argument is placed in front of the equality sign, but really it's still just putting such a closure thing into the symbol table. And if you want to know what a closure is, well, go look it up in Wikipedia.